So, we have looked before at bonding and we've talked about covalent bonding, and similar ideas apply to understanding what we mean when we refer to ionic bonding. And that is reminding you that whenever different atoms are bonding together, that is to ensure that they go about trying to fill up their outer shell of electrons, or their valence electrons, as we otherwise have called before. Now, they do that in order, as we've said before, to become stable and unreactive. Now, we've got an example here below of what happens when calcium and chlorine bond together to form, funnily enough, calcium chloride. Now, what we need to get our heads around is that for ionic bonding occurs because electrons, valence electrons in the outer shell, are transferred. So they are transferred. They're not shared like in covalent bonding. They're transferred. They're moved from one atom to another. Now, when an atom loses or gains electrons, it becomes an ion, which is an atom with an electrical charge. So that electrical charge can either be positive or negative. Now, the reason why it gains electrical charge, because when you have an atom to begin with, an atom has the same number of protons and electrons. But in order to try and get that full outer shell and become stable and unreactive, it can either gain or lose electrons. And if it gains or loses electrons, that number of protons, which are positively charged, and electrons, which are negatively charged, become unbalanced. And because they're unbalanced, that means that atom now has an electrical charge, depending on if it's got more protons or more electrons. Electrons are negatively charged, and protons are positively charged, so you can probably work out if it's got more protons, the ion is positive. If it's got more electrons, the ion is negative. Now, what do we know about opposite charges? Positive and negative attract. So when these atoms transfer electrons from one to the other, become positive or negative, because they're positively charged and negatively charged, they then attract. And that attracting of positively and negatively charged ions creates ionic bonds, such as the one shown above. So, as you'll see here in our dot and cross diagrams for calcium and chlorine, calcium is in group 2 of the periodic table, so it only has 2 valence electrons. Now, it wants to get a full outer shell, so you've got to bear in mind, for the calcium, is it easier for it to lose 2 electrons and then have a full outer shell made up of electrons that is on the next electron shell that's not shown here, or is it easier for it to gain 6? Now, the obvious answer to that is it's easier to lose 2. So those 2 electrons are lost to the chlorine atoms. Now, the chlorine atoms have got 7 electrons in the outer shell because they are from group 7 of the periodic table. Now, you look at it, and because it's got 7 electrons, and our number for a number full outer shell of electrons is 8, is it easier for it to lose 7 or gain 1? Of course, it's easier for it to gain 1. So it gains 1 electron from the calcium atom, and that electron goes to one chlorine atom and then to another. So as you'll see on the net side here, because our calcium atom has lost 2 electrons, it now has a positive charge because it's got 2 more protons. Whereas because our chlorine atoms have now gained 1 electron each, that means they've both got a charge of -1. Now, +2 and 2 lots of -1, they cancel each other out. So the positive and the negative attract to each other, meaning we end up with CaCl2, which is our calcium chloride, which is ionically bonded.